Hi, I'm Doug Atkinson here at Solutions Review, and we couldn't be happier to host the 4th annual Insight Jam. I want to thank everyone who's participating this week, as well as our Insight Jam sponsors, DataStax, Monte Carlo, Denodo, High Gear, and Seller Data. I also want to thank our Solutions Review editors and staff for pulling this event together. When we started this in 2019, we wanted to take a moment at the end of the year to celebrate enterprise technology with a social media event offering best practices and predictions. This will be our biggest jam ever, including 16 live-streamed expert panel discussions over 4 days. And we intend to keep the insights flowing in 2023 with the launch of an expert subscription site for any tech professional who wants to publish posts on Solutions Review. Again, thank you all for being here and enjoy the Insight Jam.
Solutions Review presents Insight Jam, a social media celebration of enterprise technology. Hello and welcome to the Insight Jam. My name is Jonathan Paul. I'm the Director of Multimedia here at Solutions Review, and perhaps more importantly, the MC of this year's 4th annual Insight Jam. We have a great topic today for the next 60 minutes. Encryption in the cloud now and the future. Let me bring in our panelists, have them introduce themselves, and we will get things underway. We'll start with our moderator, Artie Rahman. Take it away.
Thank you, Jonathan. I'm really excited to be here. Thank you for having me and hosting this panel. I want to start by introducing myself and making the connection between myself, my company, and the topic at hand. Encryption in the cloud is a really important topic because we have a ton of data that's been moving from our traditional data centers into the cloud, and keeping it safe is critically important. So Arti Rahman, founder, CEO of Titanium. Titanium is a data protection company. Among other things, we do all 9 privacy-preserving formats in one engine, and one of those is encryption in use. So our ability to keep data encrypted while slicing, dicing, transacting, manipulating, and keeping it that much more secure is especially relevant in the cloud. And this is sort of the connection between the topic and myself, and also why I'm really excited to have the opportunity to moderate this panel as well. I will hand over to Rishabh to introduce himself, his company, and help us understand why he decided to be on this panel today.
Thank you so much, Arti. It's a pleasure to be here, and I thank you so much for inviting me to join and participate in this panel. I am Rishabh Bodar. I'm the CEO and co-founder of Opaque Systems. Opaque is a company that was born out of research into open source from UC Berkeley. So this has been my bread and butter for the past several years, the past 7-8 years, so to speak. But our platform enables AI analytics and secure data collaboration on top of confidential data. So a lot of the data in the world right now is locked down because of confidentiality and privacy restrictions. And Opaque allows insights to be extracted and confidential data to be activated in the cloud, while also facilitating secure collaboration between entities, while keeping the data encrypted and protected at all times, even during use, similar to what Arti was talking about. Thank you so much for having me, and it's a pleasure to be here.
Wonderful. Thank you for that introduction. I want to move on and give the floor to Jill to introduce herself, her company, and also tell us why she's here on this panel to spend time with us today.
Thanks for having me. I am Jill Stelfox. I'm the CEO of Panzura. So we are a hybrid multi-cloud data management system. We take real-time files and allow you to collaborate with those files all over the world in real time. So it's all cloud and on-prem. And interestingly enough, we use encryption both in the cloud, but also on-prem, and it's how we collaborate. And we also have a recovery mechanism for a ransomware or an exfiltration attack. And so we spend a lot of time on this security topic, which is why I'm excited to be here today. Thanks for having me.
Thank you for that, Jill. Moving on to Richard, would you take a moment, please, and tell us about yourself, your company, and your connection with encryption?
Absolutely. And I also would say that I was inspired by the Captain America shield in Jonathan's background. So I'm going to change my background up in just a minute. But my name is Richard Bird, and I spent about 20 plus years in the corporate side. So my last name aside, I'm a bit of an odd bird in the solutions side of the equation. I've been in solutions for about 5 years, and I'm the chief security officer for Traceable.ai. Traceable.ai is a company that's focused on API security and API operations from a sprawl, catalog, discovery, as well as runtime and testing standpoint from a security perspective. I spent, like I said, 20 plus years in the corporate side as an operator, both a CISO and a CIO. I've had roles like the global head of identity for JP Morgan Chase. I've been CIO in high-tech manufacturing analytics. And in doing all of those different jobs, I think I bring more of a pragmatic operator's perspective to the issues of encryption. And why I'm particularly interested in the subject is as APIs continue to explode, there's a very, I think, strong concern that the current state of some 20 plus years of architecting around asymmetric encryption since the AES standard was introduced in the early 2000s is not going to be sufficient to secure transactionally, to secure from a privacy and a security standpoint. So I'm very, very interested in how we're going to progress encryption from its current state today.
Awesome. Well, thank you for that. I see Paul has joined us as well. Paul, welcome. Would you mind please introducing yourself to our guest, as well as sharing the connection between yourself and the topic?
Yeah, absolutely. Paul Martini, I'm the CEO of iBoss. There's a big area called Zero Trust right now, Zero Trust or Security Service Edge, which is this idea that, everything's distributed, resources, people, and applications. So basically applying security in a world where there's no fixed perimeters. And actually cloud and SaaS are driving a lot of this as well, because we're so used to, or we were used to having this data and application inside of a data center or inside of an office. But now these resources are scattered in all over multi-cloud environments, SaaS. So we're basically the equivalent of an airport security checkpoint in that we open the bags and we look for malware, DLP, prevent transactions, but particularly for APIs. And a big area that we're interested in is a lot of the malware, a lot of the breaches, everything's encrypted. All transactions and connections are encrypted now. But it also causes this issue where we need to look inside that transaction in order to determine whether there's a breach occurring or malware or data hijacking. And so this type of technology and decryption, even within the cloud, is going to become very important for visibility, logging, and applying security. And so that's a big area that we spend a lot of time in, decrypting transactions, applying security to API requests and to humans and all sorts of things like that. So great to be here.
Awesome. Well, thank you. So let's get our panel rolling here. Encryption can be an intimidating topic for a lot of people. So I thought the first thing we should do is just get some fundamentals out of the way. Let's talk a little bit about the concepts. So I want to cover in this particular topic the 3 states of data: at rest, in transit, in use, how encryption can be applied to those states. I'll talk a little bit about this myself, but also invite you guys. I want to talk about symmetric, asymmetric encryption. So let's clarify what that means. Pre and post quantum encryption, secure multi-party compute, those topics come up. And also transactional encryption, which is something that Richard knows a lot about. So I'll get it started. In the late 70s, encryption was invented. So it used to be DES, it became AES. It was applied to data at rest, as well as from the mid 90s to data in transit. So making those distinctions about when data is encrypted and when it is decrypted for it to be used is pretty important, because these are areas where data then gets exposed. So specifically to talk about encryption in use, there are different types of encryption in use. I'll invite Rishabh to discuss what encryption in use is, and I will complement that with a little bit of information myself, and then we'll move on past that. So Rishabh, do you want to share a little bit about data in use encryption or encryption in use?
Absolutely. So like you said, Aarti, data, we can visualize it as being broadly in one of 3 states, right? When data at rest, which means when it's stored on disk or in the cloud in a storage location. we know how to encrypt data using standard encryption schemes when it's stored. Data could be moving between locations, between a source and a destination, and that is data in transit. And we also now know how to protect data when it's traveling over the network using mechanisms like TLS and HTTPS and so forth. Data in use comes in when data is being processed, when it's being analyzed, when it's in memory and being run through using some software. Do we have mechanisms or encryption technologies that can keep data encrypted even when it's being processed is really what protecting and encrypting data in use is all about. And in some respects, it sounds counterintuitive, right? Because if data is encrypted, it basically gets converted into gibberish. How do I analyze it? How do I make sense of it? And that is really where the technological advancements and cryptographic advancements come in view, is we now have technologies that can keep data encrypted at runtime when it's being processed, while still allowing it to be used and analyzed and activated, so to speak.
Awesome, thank you. So moving on a little bit to a few other concepts, symmetric versus asymmetric, both Richard and Paul talked about this. So just for our audience, symmetric key encryption is where you use the same key to encrypt and decrypt the data. Asymmetric key encryption works with key pairs, where one key is derived from the other, and there's a mathematical correlation between those keys. This also ties into quantum and post-quantum. So with sufficient compute power, the theory is, which is now, of course, a reality, with sufficient compute power, you can derive one key from the other, which makes your asymmetric encryption be at risk with the power of quantum computers. So again, just laying some of the concepts out here. So this is something to keep in mind when we talk about quantum cryptography. But again, secure multi-party compute, Rishabh, if you want to touch on that, but otherwise, why don't you, and then we'll ask Richard to talk about transactional encryption as well.
Absolutely. So regarding secure multi-party computation, let's take an example, right? So imagine we're a bunch of banks and we want to work together to identify human traffickers or money launderers. Right now, the best that each bank can do is look at its individual transaction data, analyze that for patterns, train models on it, and then flag suspicious accounts. But any analysis that you do on individual data is naturally limited because you don't have the full power of the data available within your business ecosystem. What secure multi-party computation enables is it allows multiple entities to collaborate securely on their confidential data with each other. Essentially, each party can keep its own data encrypted using their own keys. They can combine their data sets together in a distributed way or in the cloud without exposing it to anyone, not to each other, not to the cloud provider, but still be able to train models on it, still be able to gain insights from it. And this is tied to the concept of encryption in use as well, because you are now using this data that's across different entities, but you're still able to get insights from it without actually showing it to anyone. Awesome. And there are a number of ways in which this can be achieved.
Okay. Awesome. Thank you. Thank you for that. So inviting Richard to talk a little bit about transactional encryption as well as the key management side of it. Richard, if you could do a little bit of an education for our audience here.
Yeah, absolutely. So the notion of transactional or dynamic encryption is relatively new. It was introduced conceptually by a professor in Europe, Lars Knudsen, in 2015. Kind of codified in 2017. And what's really interesting about it is it addresses the real weaknesses that are manifesting in a world that's being driven by APIs and microservices. So we talk about, Shab brought a great point about, data in use, kind of the transactional layer, but the problem that we're facing as the architectures for delivery of value are changing is that we have no encryption capabilities that are able to maintain or sustain the kind of volume, the scale, the application usage of data, the transformation of that data in flight across these APIs and microservices. So it raises a pretty sizable question. And we mentioned a little bit earlier about asymmetric and symmetric encryption. So symmetric encryption was a world of easy. When we introduced AES and asymmetric encryption, more than 20 years ago, we created all of the challenges and problems that exist relative to organizational ownership of keys, key management, how you manage, the exchange of those keys, the currency of those keys, static versus, not static keys, rotating keys. So we introduced this massive amount of complexity by introducing asymmetric, while we gain significant security benefits. But the real problem here is if you look at asymmetric key management today, it just simply doesn't fit into where the cloud-born world is moving. And so we have to look at new notions, which really raises the bar here. Are we going to try and apply a 20-plus-year-old security model relative to encryption to the direction that cloud compute is continuing to accelerate and grow?
Thank you. Paul, I imagine you'd have some commentary to add to that, being from a similar orientation yourself.
Yeah, absolutely. Yeah. Can you guys hear me okay?
Yes, we can.
Okay, good. Yeah, absolutely. So I think, when you look at hardware security modules, HSMs, that were designed to store these keys on-prem or within a data center, like how do you deal with key management or storage of the key in environments that are not just, AWS, but as this data gets scattered across organizations that are not even within the same organization as we were speaking to earlier. I think that the challenge, and you mentioned quantum computing as well. The challenges are exponentially getting worse. I don't think that obviously asymmetric encryption introduces a lot of problems, but it needed to be a solution at the time because people that access banking sites, for example, aren't going to have secret keys that they store or anything like that. But as we move into the future here, this whole notion of key management, I think that's probably one of the hardest parts of this equation is the management and the storage of the keys that is now moving from perimeter-based data centers to, distributed data sets.
Yep. Well, thank you. So Jill, may I invite you to comment a little bit on quantum and how real it is and whether it's a science experiment or it's something more real today, because I know you have some views on that.
Yeah, I was recently on a panel with NIST talking about the hope of quantum. And I think we're a long way away. I think we're as long as 10 years away from being able to manage something like that. I do think it's an important change, and I think it is certainly something that will improve how we do things today. I mean, we've all talked about it already, right? This encryption hasn't changed dramatically in 20 years, but technology has, and architectures are so different. So we need something, but I think we're a ways off.
Okay. Well, thank you. So some of the groundwork has been laid for this conversation. Now let's actually get into encryption in the cloud. So first question for the group is, why is it even important to encrypt in the cloud? It's a little bit of a, obvious statement here, so I'll color it a little bit. Can we talk a little bit about attack vectors and which ones are cloud specific? And how things have changed as we have moved from on-prem to cloud with respect to these attack vectors. So I want to start with Jill. I know she has a good sense of both the data being utilized as well as stored on the cloud. So Jill, gonna shift the spotlight over to you for this one to kick us off.
Yeah, I would say the attack vectors are very similar in the cloud as they are on-prem and in data center. So much is the same, right? You can have everything from, pop-ups, emails, web pages go awry, all those things. I would say the thing we see the most is that cloud buckets themselves are inherently insecure until you secure them. And so you have to take an active role in how you set it up and how you choose to control it. And it is probably the number one thing that we see is that large entities don't do this in simple ways. Maybe their main S3 bucket, for example, has the appropriate level of security, but they set up a dev environment or a non-prod environment, and that doesn't, yet you can still, get in through there. And so I think it's one of those things that you have to look fairly holistically on.
Thank you. So I'm pretty sure, Paul, you have some commentary on that. So, with so many applications transacting data in and out of the cloud, Do you want to add any color to what you think additional attack vectors might be?
Yeah, look, I think if you look at the NIST 800-207, the zero trust architecture, and why zero trust is such a big thing right now is this idea that it's not just, most people think of it as humans, like humans are working from home. But the real problem, and just as big of a problem, is that the data and the resources are scattered everywhere, including the cloud. And once that happens, like our mindset is so focused on physical perimeters and physical access, because we've been, this is what we've been around for decades, that when it moves to a cloud-based environment where a security admin or an IT professional is used to physically maybe setting up a firewall or physically setting up where the data server is and the data sits, they can lose sight of that when it moves to a SaaS-based model or a cloud-based model because they can't physically see it. So you end up with these scenarios of misconfigured buckets and other things like that would normally be more locked down in general. But I think that really, to me, it's the access, the availability of cloud, which has its benefits because it's so accessible and people can be so productive. But on the flip side, it's the accessibility to the attackers, which is the root cause of, if you look at any of the initial infection vectors with CISA, it's unauthorized access to data and applications. So old days, how do you get into that data in that you would have to break into the data center? You physically have to. I actually even hear sometimes, just recently someone said, we have technology appliances, for example, that decrypt the data so that we can run intrusion prevention and DLP on the decrypted data. My thought is, you're running plain text data over wires. They says, well, there's we have pages and locks. And I said, what happened at Target? I mean, it's that we could talk about physical protection. Now you move this over to AWS or other places, and there is no physical perimeters. The problem gets exponentially worse because the access is so exponentially higher to the people that we don't want access to this data.
Oh, absolutely. Rishabh, you're nodding. You have something to say.
Yeah, I think in the sense that now everyone is moving to the cloud, right? Undergoing digital transformation. So a lot of bad practices, or not necessarily super secure practices that you get away with when your data is entirely on-prem, you can't necessarily get away with that when you're on the cloud. Like Paul and Jill mentioned, you now also have to worry about the threat of attackers and hackers. You may need to worry about co-tenants who might be using the same infrastructure as you on the cloud. And all of these are additional vectors of attack against which you need to reason about. And now you need to make sure that the data is encrypted and protected at all times. So I think this also, in a sense, ties back in with the encryption and use requirement, because now you're running data, processing data on machines that are not within your own data centers. So how do you keep that protected? How do you keep that encrypted?
So, Arti, I'd really like to jump in on this one, because this goes back to the operator's perspective. I'm reasonably well known in the security solutions industry for making contentious statements, so I give an advance warning on one. But look, the most common attack vector in the cloud is the stuff that's not getting managed correctly in the cloud. It's just that simple. And I think this is a really fascinating problem that is not getting addressed, which is, and Joe brought up a great comment about, the how the buckets were managed. I'm going to actually share a real life story. It is a breach that most people are very, very familiar with. It involved a contractor. I won't name names here, but it involved a contractor who had VPN access into a cloud service provider and simply made a production copy of a bucket. And why that story is so interesting is because there's a tie directly to encryption. In a window shop forensic that I was doing as a customer in that equation, I said, well, I don't get it. I said, how did somebody, use their access to make that copy? And the response was, oh no, they used a functional account, right? So they used an account intended for data transfer between applications within a cloud to be able to create that copy. And I said, well, great. And I said, what about the monitoring on that copy then? Oh, once it's not production, we don't monitor it anymore. And I said, okay, well, here's the third question that I have for you. How did they get the keys? Because this was a financial services institution. How did they get the keys in order to be able to decrypt it at rest? And the response was, the keys were associated to the functional role. Now, let's pause for a second, right? That is a 15-year ago problem, right? That is not this is cloud-born applications, native in the cloud, massive migrations to the cloud. We shouldn't be seeing those kind of things because we learned those lessons 15 and 20 years ago in the data center. However, The lessons that we have learned have been broadly vacated across the cloud solution providers, either technically or functionally, in terms of who wears the risk and liability in those cloud contracts. And because so much of the operational responsibility for security and key management in particular still falls back on the company that's leveraging that cloud service provider, we are seeing the attack surface just simply be the space of misconfigurations, mismanagement, misapplication of encryption and security keys. And it's happening over and over again, and it seems to be accelerating.
Yep. No, I have to agree with you, Richard. I think summarizing what you all have said and adding a little bit of my own thinking on there, the attack surface majorly went up. The unmonitored attack surface went up. There are more hands on the data, depending on how encrypted you can keep it, more admins, more users, more access. And then there's a notion of this data supply chain, or whatever you want to call it, where data owners are different from data processors almost all the time now, whether it's in the context of SaaS or it's in the context of other, cloud collaboration. So I think for all of these reasons, it is really important to think about how you're going to secure that data and have an encryption strategy for the cloud. So this is a nice segue into our next topic, which is, if you were to have an encryption strategy for the cloud, how would it be different from what you did on-prem? What would be the challenges of encrypting data in the cloud? The most obvious one being that, cloud processing actually needs to happen. And so I want to go around the room and ask that question. So Richard, you have fantastic color on the previous one. So we'll start with you on this one. What do you think the challenges would be? And then which ones have been addressed and where are the gaps?
Oof, wow. I think that when we look at applying, encryption strategies in the cloud, it actually starts with a lot of stuff that has nothing to do with encryption. Rishab, you mentioned, behaviors from the past. I think it's really interesting. The business side of the equation, which we don't typically talk about when we talk about things like encryption, are creating a world where this old habit that we used to have in, say, data centers of keeping copies of copies of copies of copies has not been mitigated, right? So when we look at cloud service providers, people talk all the time about the distributed compute became the most powerful aspect of the cloud. That's completely incorrect. Cheap storage is what has made the cloud so valuable. The problem with that is that cheap storage has created a propensity to keep way too much data, more data than is needed, just in case we're going to need it, right? Now we get back to what Jill said, which is a very obvious lack of discipline in applying encryption requirements or encryption processes around all of this exploding amount of data facilitated by cheap data storage as a commodity. So I think one of the things that has to happen in cloud when we think about protection of data from either a privacy or pure security standpoint is, am I only operating with the data that's necessary to deliver value, as opposed to, am I trying to also then manage tremendous amounts of data that are not directly responsible for delivering that value, either to the consumer side of the equation or internally. And then I think that, when we look at the application of encryption in cloud service providers, it looks like every architectural diagram we ever had in our own data centers. So I think one of the things that you have to consider when you're looking at what you're going to do for your cloud encryption strategy is how am I going to do it differently? Am I going to rely on this old architecture and old structure? Whereas Paul, put it so well, that perimeter is gone. And let's face it, asymmetric key management is a perimeter-based strategy for security. It is not a perimeterless-based strategy. The idea of applying encryption at the data level, back to Paul's points about zero trust, yields the possibility of a zero trust outcome. But it all begins with the fact that we're carrying too much data to begin with. So one of the things that has to happen is we have to quit treating encryption discussions as if it's a bunch of people in a small corner in a dark room that are just figuring out the cryptological components of this, and start to incorporate those conversations into the broader business transaction flows of what we achieve with cloud-born applications and microservices and those types of things.
Paul. What do you think?
Yeah, no, looking back, if we think about how many financial institutions have had legacy software that's so old and so maybe even Windows XP, yet those things haven't been, they don't get breached. They take a while. They eventually get breached, but we're getting the rate of breaches is so high because of access now that you just can't live in that type of environment where you're protected by lack of access. So you need to change the way access is granted, right? And I think particularly going back to key management, because it'll be a little bit until quantum computing comes around, is I do think you can't host an HSM or you can do it, but it's like, how are you going to apply that in a lot of different places? So I personally like things like key management systems that are offered by cloud providers, which abstract the storage of the key and use APIs for access and things of that nature, because I think it simplifies key management in general. It actually should make it a little bit easier. There's still going to be the mistakes of the person who grabs those keys and ends up storing them and using them incorrectly. But I think it makes the key more programmatic, more accessible in a more distributed environment. I also think that ultimately encryption needs to be part of the overall design process. So it's like the comment that was just made about this is just something that people do in a dark corner. This is something that everybody needs to understand pretty well, so that they can foundationally design software that is secure to begin with. And I think that's going to be really important.
Thank you. Sorry, Risha?
Just one thing to add. So on that, so Paul, something that Paul mentions stood out to me as well. I mean, I think Richard's right, but we also need to move away from institutional trust to programmatic trust. Like, you shouldn't have to rely on a piece of contract or processes are important, but can the technology itself provide me assurances such that in the event of a breach, my data still remains protected, still remains secure? I think that is key, and that is what we need to be looking forward to, what we need to be moving towards as an industry when we think about protecting data in the cloud. Just moving from institutional to programmatic trust.
Thank you. I wanted to invite Jill to comment as well on the challenges of keeping data encrypted in the cloud, Jill, both with respect to processing and transacting data as well as storing it. There's a ton of data stored in the cloud as well. And we know attackers now are sophisticated enough to move from data that's being actively used to data that's in storage, and all of the malware, et cetera, seems to find its way to there as well, which interrupts your resilience and your recovery. So what are your thoughts, on some of those challenges that are a little bit broader in terms of their data coverage?
Yeah, I think, going back to what Richard said, I really do believe that that these S3 buckets have become kind of a wasteland of data that probably shouldn't be kept, to just say it bluntly. And so the challenge is that people think about encrypting their most important current data, but they don't think about the piles of things that are out there unencrypted. And in fact, we have seen over and over again with our customers where they actually have had rules in their data center that say, over this length of time, we don't really care so much about security and encryption. And now it's in an S3 bucket and it's flying blind. And guess what? That's where the problem starts. And so we also think like Rishab about how and where encryption is handled with data. And it's very programmatic in how we deal with it. But it's so fascinating to me that even these discussions around what's important to encrypt and not encrypt are conversations that we're having as it relates to the cloud. Because I'm not sure people understand that it's all there and all available versus the old data center way of thinking.
Thank you. So adding a little bit of color from my own experience as well, I think that the technology has come along to where we can apply encryption in the cloud to data in its various states, etc. At rest, in transit, in use. We can shard it, we can secure keys, we can split up keys. There's a lot of that at least available as far for those that understand. In my opinion, one of the biggest challenges is actually making it available, making it accessible, making it less intimidating. And this is where the programmatic aspect comes in. So what can we do to bake in encryption, etc. And I think if we can start solving that, so can we have simple plugins that attach onto data platforms, services that run alongside our different cloud services and cloud data services that allow people to spin these security services up as along with their data services. Because I think at the end of the day, there is a little bit of an intimidation and complexity factor as well, which gets in the way of keeping data encrypted. We are doing pretty well on time. So if there are any other comments on both the accessibility aspect of it and making sure that maybe applications and data can be born in a little bit more secure way as it gets to the cloud. Richard, can I invite a comment from you on that?
Yeah, this is definitely where my personal interest strikes, because the numbers are astounding. Pre-COVID, we had been about 8 or 9 years into APIs and a couple of years into true institutional enterprise microservices. Through COVID, the number of APIs in use exploded at the corporate level, and we're beginning to see the outcomes of that, which are breaches and exploits that are focused on the API layer, or as well the data layer, since APIs have such a high transactional interaction with data stores, and we're starting to see the results of the inadequacies of the current state of encryption. Forget the quantum conversation, which is still a valuable and interesting conversation to have, but forget the quantum part of the conversation. When we look at something like the Optus breach, which happened now about 2 months ago in Australia, we have a publicly exposed endpoint that was not supposed to have been, and 10 million customer accounts were siphoned off of that endpoint immediately. And there's not, the problem with this space is that nobody noticed because the API worked as designed, yet there were not the types of encryption capabilities around the data itself to be able to protect the citizens in Australia that are now very much impacted, and now the Australian government is very much getting active on resolving those particular holes within their compliance structure, their compliance framework. So, when I look at this this encryption space, and when we look at this API space, we see a tremendous amount of power now that is being able to be used, not even by really well-seasoned people in DevOps. You just simply go out and grab what you need these days. Nobody codes anymore, right? Nobody talks about elegant in terms of how we build applications anymore. You just simply go out and grab the bits and pieces that you need, from this DLL or GitHub or wherever, and it's creating even worse outcomes than we used to have around developers and their thinking about security. We're starting to see this behavior pattern where security is somebody else's problem, which would be inclusive of encryption, when we're looking at this rush to greatness in cloud applications and cloud services. And so, again, I feel like the topic of encryption is becoming less and less of a concern with the populations that really have the most need to make sure that they're leveraging it. And we need to really figure out how we're going to address those gaps.
Yeah. Well, an interesting story comes to mind for me. Our company does encryption in use, among other things. And while we've been working with companies on figuring out when to keep data encrypted while it's transacted and when to decrypt it, we did a little bit of analysis and found that in this particular company, this is a large security company, over 95% of the time, there wasn't a human being that actually needed to look at and process that data. And if there isn't a human sitting in front of a monitor, you should actually be processing that whole thing encrypted. So when we plugged our technology into their SOC solution, which basically we were running encrypted playbooks, etc., we found that 95, 98% of the time, you didn't even need to decrypt at all, whether it was an API call or what have you, which was very interesting. So I think, as technologies process forward and progress forward, we could potentially even minimize how much clear text does flow, even when you have legitimate accounts calling for data. So I want to also invite some commentary from Paul on this aspect, limitations of encryption, challenges of encryption specific to cloud, training, accessibility, any of those, any thoughts on those?
Yeah, no, look, ultimately, I think it's unauthorized access is the root cause of a breach. I mean, if data ended up in the hands of only the people that should have access, we wouldn't have a problem. But I think that if, for me, this is why what NIST is doing with 800-207 and Zero Trust is so important, and why the federal government in the US at least is moving to these models, and worldwide Zero Trust models are becoming so popular, is if we can solve for unauthorized access to begin with. And to your point here, even to the case, and you can be as granular as can be, that if you don't need access to the decrypted data, you shouldn't. I mean, you should have the least amount of access needed to do the job, whether it's a human being or technology. So I'm a big believer in actually in terms of not just microsegmentation, because a lot of people think of that from a networking perspective, but really per request transaction decisions. And actually NIST in the 800-207 talks about that, and I think it's broadly misinterpreted of what that actually means. They say, down to an API call, you should make a decision on whether that transaction should or should not occur, as well as what should happen with that transaction. To your point, if the data shouldn't be decrypted, it should just stay, it should remain that way, and the data should just be transferred. And so I think as I look at different interpretations of what continuous adaptive access means, many think of this as, I granted someone access when they logged into, the identity provider and did multi-factor. But continuous adaptive access, even according to NIST, is every single transaction, there has to be a decision. And there has to be least privileged access for that transaction to occur. And the only way you can really reduce the risk is to reduce the surface area. And I like your comment there, because it even goes beyond the application. It goes right into the data itself to really come up with context and what they call trust algorithms to determine what happens and what doesn't happen when you're working with data. So I'm a big proponent of that.
Thank you. Rishabh, you haven't had a chance to comment on the key challenges and limitations bit of encryption in the cloud. Did you have a few thoughts you wanted to share?
Absolutely. So one aspect of, so there are two parts that I see to encryption. One as a mechanism to increase the security posture of organizations and just control access to data and limit access to data. But the other aspect is that it can also be an enabler for better business decisions and better business outcomes. Right now, a lot of data is locked down, right, in silos. This data can't be shared across teams within the same organization, let alone outside organization boundaries. And as a result, a lot of the value that is inherent in this data is going lost. It's going untapped. Encryption in use has the potential of unlocking the value and activating confidential data as well, while simultaneously increasing an organization security posture. So one gap that I see in current encryption strategies around data encryption is that, yes, we have widely deployed solutions for data protection at rest and data protection in transit, but data protection in use is key not only to closing the gap as far as an organization's security and confidentiality is concerned, but it can also be a driver for informing better business outcomes, things that you couldn't do before, like sharing data across entities or with your business partners and within your business ecosystem, now become possible as a result as well, because you can keep the data protected, you can combine it, but you can still get insights from it. So I think this is one aspect that we will see more and more development and excitement around going forward.
Thank you. I want to also draw our attention to the idea of ownership, which in the case of encryption is driven by keys. Who owns the keys? Where do the keys live? How are the keys managed? And in the context of privacy, which is sort of a parallel topic with security, which also has a lot of encryption-based enforcement, I want to talk a little bit about ownership. So now in the context of cloud, we have bring your own key, which has become hold your own key, which allows data owners to both supply keys as well as hang on to them, turn them off to deactivate their data in the cloud. And from my own experience talking to a large number of companies, the results are mixed so far. So I wonder if this group has thoughts on ownership, key management, data residency as it relates to ownership, and some of these other related areas as well. So Jill, you haven't shared your thoughts in this go around. So I want to invite you to start commenting on keys and key residency, etc.
So I'll give you a real story on this. So we work with one of the largest mortgage processing companies in the US. And when you process mortgage data, you often have to share that data with third parties so that you can get approvals for things, and all kinds of information goes back and forth. Who holds the key at any given time has two important parts. One is security, and the other is who owns the data as it relates to making a good decision. So there are, we created in our software, this is all about architecture and how you really think about it. And so it's really important to be able to trace who's doing what to whom as it relates to the data and who owns it at what stage. And so being able to think through ahead of time how your process works, how it works in the cloud, how it works in a remote instance. I mean, you might imagine we've been processing mortgage loans for the last 2.5 years, all during COVID. So everybody's remote. How do you make sure that it's secure all the way along and the right person holds the right key? It's a big, big challenge in terms of key rights. We literally did it by creating a world where people, through our software, where people can share information in a very secure way and hold their own keys. We do the same for large gaming companies too, where their assets are, everything from code, but more importantly, images. And so who owns the right to the image at what stage? But this is a big, it's a huge area that needs improvement.
Yeah, no, absolutely. We care about this as well with respect to my company, but I want to invite Paul and Richard to comment as well on the key management side. How about you, Paul? Any thoughts on bring your own key, hold your own key, ownership, things like that?
Yeah, I think this goes back to the whole conversation around, more legacy approaches to key management, HSMs and things of that nature. And I think programmatic approaches to not just accessing keys, but where the keys get stored. And also access to it's not just even about sharing the key, it's how do you give people access to the key and, possibly even expire them, when they're no longer needed. But I think compliance and regulation is a big thing. I mean, it's part of this is security, but the other parts like GDPR and data residency requirements become very, very important as well. And I think ultimately, maybe some of those drivers legally will push, it's interesting how sometimes it's like the laws that actually may affect security because you're trying to do something in a certain way, which might not be the most optimal way, but it's to remain compliant. And so, I think that the regulators, I think that NIST is doing a great job with CISA, really thinking about what are the business needs for any company to remain relevant. You can't just decide you're just not going to do SaaS and cloud and that sort of thing. I mean, and it's actually not the best in terms of delivering value for customers and to the world really. So you have to balance that. I think that having government pair up with commercial sector and enterprise sector to come up with things that make the most sense and work together to come up with the best solutions for managing the keys and the technology that should be standardized. Because I think standards, the cloud I think has been very successful because we went from XML and all sorts of different things to JSON and standardized HTTP REST calls, right? So I think once the standards are there, then there's a way that everybody can communicate in the same way. And I think if that can happen in this encryption area, it'll have a huge implication because everybody can learn against the standards and the way, an easy way to communicate and transfer this type of information.
Thank you. Richard, you care a lot about keys on the transactional encryption side, so maybe a little bit from you on this would be fantastic.
Yeah, I like where Jill went because I think it highlights the significant problem that we have with key management today. right? The key management structure is still dependent upon a couple of different, key items, right? You key ownership, who owns the management of those keys, right? And then and the result is that typically for the vast majority of what gets matched, those keys are persistent, right? And then Paul mentioned something about, do those keys need to be deleted? Well, I don't know of many companies that are exceptionally good at managing the hygiene of their key distribution. And yet we're in this world now where keys laying around actually has a substantially bigger consequence from both a risk and an exploit standpoint, as it relates to who can get access to which transactions and which transaction flows. So I think that we're trying to backfit a key management model that just simply doesn't address the use case that Jill mentioned so well, which is what if we have a mortgage processing situation? Many of us have refinanced over the last couple of years. We're very intimately familiar with this. And I don't have just a third-party single service provider. I've got a notary service provider, and I've got a county service provider. I've got 6 or 7 different actors that are associated with the execution of that particular series of transactions. We haven't developed a key management system that actually addresses a 6 or 7 or 8 party type of distribution of the same data across all of those different personas. But that's the reality of what we've been able to enable with cloud technologies. So I think we're definitely coming into this space. Key management is just one of those areas, but I think we're coming into a space where the weight and the friction of the old architectures is just simply buckling under the capabilities and the potential for what we could, like it was mentioned earlier, like the data that we could be extracting, because we're trying to backfit this aged model to manage cloud-based transactions and microservices.
No, thank you. I completely agree with you. I also think that even as we have so many new technologies, our ability to apply those to greenfield development is so much stronger than our ability to go back and retrofit against all the legacy data that's out there. So definitely we need a little bit of catching up to do. Rishabh, I didn't invite your thoughts on this topic. Let's get your thoughts here, and then we talk about the human side of it a little bit, building a program.
I think the problem gets even more compounded when we start thinking about data collaboration scenarios. So, for example, advertisers wanting to share data with publishers, or an insurance company wanting data from its partners to identify where their workers' compensation claims have gone up. All of these scenarios where you require data to be shared across entities that are confidential in nature and therefore need to be encrypted become even more problematic when you're not able to share that confidential data with others because of privacy laws and regulations and so forth. So solutions that can enable proper key management and encryption to be maintained and guarantees to remain in place while also facilitating multi-institution collaborations is paramount. And we'll be seeing more and more of that going forward.
Awesome, thank you. One of the thoughts I had listening to all of you talk is we didn't talk about what's confidential data-wise in the first place. So you know how before we used to have 13 things that were on NIST's definition of PII. I think that has also changed now, right? Data can be combined. In fact, I was in a conversation with a customer where we were talking about securing chat logs. And one of the things we do is searchable encryption. So kind of file that away as context. So securing chat logs, and traditionally you'd point DLP at it, and you do a okay job, maybe not so okay job catching what's sensitive. But these days, the entire thing can be sensitive. So how do you stay on top of that? And we talked about, in the context of our technology, encrypting the whole thing. But I think it highlights a very interesting challenge of what is sensitive in the first place. If it was on-prem, you could have gotten away with a narrower definition of what is sensitive versus in the cloud. And you could have all of your traditionally defined PII be highly secure, have a breach, lose some data, and still be in trouble for it in the context of cloud. So that was, a little bit of color I wanted to add there. But I think we are coming up on the last 2 or 3 minutes of our conversation. So Jonathan's here. I was going to go into some closing comments, Jonathan. Maybe you can take that over from me and invite those comments, and then we can go around the room and close out for the day.
That sounds like a great idea. Artie, you just went. So let's start with Rishab. Final thoughts, 30 seconds or so. Anything you'd like to sort of put a final note on with this topic, or any solution or site you'd like to promote and share with our audience? Take it away.
Thanks so much, Jonathan, for inviting me. Thanks for moderating this panel, Artie, and it was a pleasure meeting Jill, Richard, Paul. If you're interested in learning more about Opaque, please feel free to reach out to me at rishab@opaque.co, which is our website. We provide a solution for confidential computing on top of encrypted data and enabling analytics, machine learning, and secure data collaboration. And I'll be happy to chat more and deep dive more into what we do.
Excellent, thank you. Jill.
Jill Stelfox, I'm with Panzura. You can find us at panzura.com. I will leave you with the latest security reports are saying that 95% of companies are having an API security event or incident in the last 12 months. So pay attention to your APIs as it relates to cloud.
All right. Paul.
Yeah, this zero trust is a big thing for us. The NIST 800-207 zero trust architecture, I think, is the wave of the future. So anyone or anybody working on implementing a NIST 800-207 zero trust architecture, which fundamentally goes down to preventing unauthorized resource access as well as providing security, should take a look at us. This is iBoss. Thank you.
All right. And Richard.
Yep, Richard Bird, and then easy to find me. You can track me down at traceable.ai. Richard at traceable.ai is that email address. Catch me on LinkedIn. Catch me on Twitter at traceablebird. You can't throw a rock and not hit me. So super easy to find me. My last parting item that I'd kind of toss out there is, we talked a little bit around the edges of quantum. Look, here's my advice. Before you make quantum cracking a major concern for yourself, go address 19 of the things that we as collectively talked about as a group as it relates to your security architectures today. Either a security architecture that's fit to manage your cloud or hybrid realities, or a security architecture that actually is focused on where the real problems are today. Paul mentioned authorization, authentication, the whole identity side. There's a lot of things that folks should be focusing on rather than worrying about quantum cryptojacking.
Excellent. And Artie, to close us out.
Thank you so much. So I wanted to share just briefly about what Titanium does. We do 3 things: encryption in use. So we allow databases and applications to process data without decrypting it. We also give you all 9 privacy preserving data security formats in one engine. So think vaulted, vaultless tokenization, static dynamic masking, redaction, hashing, anonymization, all of the things you did traditionally, giving it to you in one place as part of that value proposition, along with encryption in use. And we also do hold your own key at scale. So the idea is that in the world where data owners are different from data processors, Titanium can be utilized to keep that data secure. Titanium is spelled with an A, not a U, so Titaniam. So you can find me at arti@titanium.io. And I'm also very active on LinkedIn. Welcome connections and conversations there. Thank you so much for giving me the opportunity to moderate this discussion.
Yeah, and thank you for doing such a great job of it. I would like to thank all of our panelists again for their time and you for your attention. I hope you stick around for the Inside Jam. We're doing it all again tomorrow with 4 hours of back-to-back panels discussing backup and disaster recovery. You don't want to miss it. It starts right here across the Solutions Review social channels, Twitter, LinkedIn, and YouTube at 11 a.m. Eastern. Once again, my name is Jonathan Paula. Thank you so much for joining me and our panelists today. Thank you for watching, and we'll hope to see you tomorrow.